Hello, this is Dr. Mears, and today we are going to be learning about functions in our course, Applications and Interpretations SL1. A function is a relation between two sets in which every element of the first set, input, which is the independent variable, is mapped onto one and only one element of the second set, output, which is the dependent variable. So let's just take a look at this using dots and A's and B's. So here we have our input. Our input is going to be A. We have this one dot, which is mapped onto, that's the arrows, meaning the arrow is going from the input to the output. That's what it means to be mapped to. Here we have the input is being mapped to one output. So this is called 1-to-1. This is a function. Each input is mapped to only one output. Let's look at this input and output. Here we have input, our A. Our first point is being mapped to only one. We only have one arrow going out. The second one, again, we only have one arrow going out. It's okay that they're going to the same output. That's okay. And the third one, again, is mapped to only one. So while this is many to one, it's still a function. Okay, let's test this. Let's see if our ordered pairs are going to be functions or not, and we'll say why. Okay, number one. Now, instead of using A's and B's, what we're going to be using are ordered pairs, X and Y. So for number one, this one is our first X, X1, and this is our first Y, Y1. So when you see those subnumbers, they just mean that it's the first point. Then the next one, this is our second X, and this is our second Y. And moving forward, this is our third X, and this is our third Y. And that's how we label the points using our subnumbers and our variables X and Y. Now, when we make our map, instead of A and B, we're just going to have X and Y. In X, what we're going to do is we're going to look at all of these first numbers, 1, 2, and 3, and we're going to put them in order, 1, 2, and 3, and we're going to draw a circle around it. Then we're going to look at all of our Y values, our second values. We have 2, 3, and 6. Those are also in order, which is great. Okay. Then we're going to go to each ordered pair, and now we're going to draw arrows or map from the X to the Y. The first ordered pair, we're going to be mapping from 1 to 2. The second ordered pair from 2 to 3. And the third ordered pair from 3 to 6. And what does this look like? It looks exactly like where we started, where we have 1-to-1, which means it is a function. Okay, let's do number 2. So number 2, we have 1, 2, 3, 4 ordered pairs. Remember, the first number is your X and the second number is your Y. I'm not going to go through and label all of these because you could definitely do that on your own. But I am going to set up our X and our Y. I am going to look at the first numbers here because those are our X's. The first numbers I have are 1, 2, 1, 1. Now, these ones repeat, which is absolutely fine for writing them down. We just don't need to write them twice. So once you write the 1 down, you don't have to keep writing it down again and again. So just write it once and you're good to go. All right, let's look at our next number, 2, 3, 4, 5, and we could just write it down just like that. Let's draw some circles, and let's start mapping. Our 1 goes to 2. Okay. Our 2 goes to the 3. Looking good so far. Oops. Okay, our 1 now also goes to the 4. And our last point, our 1, also goes to the 5. Now, do you see how we have 3 different arrows coming from 1? We cannot have that. This is not a function because we have one number going to many other numbers. It's actually going to 1, 2, 3 other numbers. So we cannot have that. That is not a function. Okay, and let's look at the last one. I'm just going to label the first point x1, y1, just so that remember which one's x and y. Let's label x and y. Let's look at our first point, 1, 1, 1, 2, 2. I think you can feel that it's probably going to not be a function just because we have these ones repeating. All right, so in our x's, we only have 1 and we have 2. That's it. We don't have to write them down again. I know they're repeated. That's fine. The arrows will take care of that for us. In our y values, we have 2, 3, 4, 2, 3. So 2, 3, 4. We already wrote the 2 down, and we already wrote the 3 down. So that's all we're going to write. And let's start mapping. 1 to 2. 1 to 3. 1 to 4. 2 to 2, and 2 to 3. Okay, so do we have many arrows coming from this first column here? Yes. And do we have many arrows going to the second column? Yes. So it is not a function. Once you have more than one arrow, it's not a function. Going to something else. So, and this is many to many. Many arrows to many other arrows, so not a function. So hopefully you can see here, these are some really good examples of what not a function is and what a function can be, and the reason why. Okay, let's keep moving on. What can we do with functions, and what are our other names for x and y and inputs and outputs? So in mathematics, we take a concept and we have many different names for it. So instead of saying x, what we can call, or instead of saying input, we can also name it the domain. The domain of a function is the set of all input values, which is our x. Our range of a function is the set of all output values, which is our y. So instead of saying x and y, we're going to be labeling it as domain and range and looking to see what those set of numbers are. I have a nice little table, little graphical, not table, little representation for you, visual, that's what I meant. So we have input, which is x, that's the domain. So these are all go together. That's mapped onto, there's our arrow, our outputs, which is our y, which is also going to be known as range. So that's definitely a good visual representation of what I'm trying to explain. Let's see how we can use these examples. So number one is sketch the function of y equals x plus 1. And what I'm going to have you do here is take out your graphing calculator. And when you take out your graphing calculator, I want you to notice this y equals button. And when you turn it on, I'm going to clear this out. What I want you to do is I want you to press that y equals button. So I'm going to write the directions up here. Y equals, okay, to sketch. All right. So we're going to press that y equals button. If you have anything up here, then you're just going to clear it out by pressing clear. Sometimes I like to even go down. It goes all the way down to 0, 9, and then that's 0. So I like to make sure that there's no other equations there, just in case somebody else put them in. It could mess us up. All right, now what I'm going to do is I need to put in this function. This is our function for this example. In your classwork, in your books, you're not going to always use this. This is just for my example for this video. So be careful, make sure that you locate what your function is that the book or the example gives you. All right, so in order to put this in, the only side we're going to put in is this. So the calculator already has y sub 1 equals. So this button right here, xt theta n, this one right here, xt theta n, that is our x. So you can push it and you can always get x. The reason why it has all of these other markings is because sometimes we might have a problem with a t in it, or an n in it, or a theta in it. So this represents that variable. And then we're just going to press plus 1. So y equals, we're going to clear anything out. Then our xt theta n button, that is going to be our x variable. And now what we're going to do is we're going to press zoom. And make sure my lights don't go off because they start to go up. We're going to press zoom, and zoom is right here, right in the middle. And what that's going to do is bring you to a menu where you can see we can zoom in on a graph, we can zoom out on a graph. We also have this number 6. This is zoom standard. And we're also going to be doing zoom fit, which is down here. So noticing all of these different ways to zoom in on our picture, just like you would on a cell phone, what we're going to choose today is Z standard. And what that's going to do is it's going to give us a graph that counts by 1. The scale is going to be 1. And it goes all the way up to 10. So let me show you what that looks like. So go to Z standard and you could press enter. And so what this graph does is it counts by 1, 1, 2, 3, 4, and it goes all the way to 10. That's why it's a standard graph. Here it goes to negative 10. Here it goes to positive 10. Here it goes to negative 10 on the Y, positive 10 on the Y. So it's nice because if you look at this graph, we can see that the graph crosses positive 1 on the Y and negative 1 on the X. And this is how you're going to sketch it. So let's do that. You do not have to put all of the numbers on here when we sketch, but what we do want is we want some labels. So I am, oops, sorry, don't write that. I wrote it backwards by accident. 0, 1 and negative 1, 0. So we want 2 major points for where our line crosses, and then you're going to sketch the line. Okay. So let's talk about the word sketch. In IB, there's a difference between sketch and the word draw. I'm going to put it up in the corner because we're going to be focusing on drawing later. What sketching does is it says, okay, we just want to see overall what the picture looks like, a couple major points that it has on it, and that's it. So we don't need anything detailed. So here I did my axes and I put arrows. I labeled my axes X and Y. I labeled 2 major points in which all I did was I counted. That's all I did. It's a standard graph. So I just looked and I saw where it crossed. I wrote those points down and then I drew my line in. That's it. You don't need anything too detailed. When we get to draw, that's when we get into detail. Draw detail. That's when we have to be perfect. We have to have a scale. We have to have all the numbers labeled. Everything has to be immaculate. We're going to get to this later. Let's just sketch and learn how to use the graphing calculator. And I'm sorry for my little Band-Aid on my finger. I cut myself, so. Okay, number 2. So that's how you sketch it. Oh, also, if you wanted to know the points, there's this trace button right here. If you press trace, you get a little blinky dot. See that little blinky dot? And look at that. There's the point, 0, 1. And we can even move over, and we could try to even get on the point -1, 0. So that really helps you to get those points. So that is the button trace. I'll write that in down here. We can press trace if we want. And that'll help us to locate some points. Okay, now what we're going to do is we're going to see if this function, y equals x plus 1, using this graph to see if it's a function. And what we're going to do is we're going to use the vertical line test. And I always like to say VLT so that I don't have to write it all out. So what we're going to do is we're going to, just like what we did for our maps, we're going to go back here. Just like what we did for this, we were able to tell if it's a function or if it's not a function. And we used mapping to do that. Well, we don't have a lot of ordered pairs here. So if you have a graph and you're asked to see if it's a function, what we're going to do is use the vertical line test. The vertical line test says, if I take an imaginary vertical line, and I scan my graph from left to right, anytime I stop my vertical line, it's only going to cross my graph once. So if I stopped my vertical line right here, it is only landing on this line right here that I just drew in, once. It's only landing right here. It's only touching it once. Even if I stopped over here, still just touching it once. If I started scanning again and I stopped my vertical line here, how many times is it touching this line? Right here, just once. So let's just write that in. Imaginary vertical line when scanned from left to right. You can go the other way too. I just like left to right because that's how I read a sentence. Can only touch graph of line, or you could have a curve once. So what are some, and that's a function. So this here, this is a function because it passes the vertical line test, okay? What does it look like if it's not a function? Okay, let's do that over here. Not passing, VLT, okay, which means not a function. What does that look like? Well, I'm just going to do a couple rough drawings. So let's say that we have X and Y, and we have something that looks like this. Okay, so here is my curve. I take my vertical line, I start scanning it, I stop it right there. What my vertical line, the parts that my vertical line are touching, here's my imaginary vertical line that I stopped. It's touching the part, this graph above and this part of the graph below. That is not a function. Let's look at one more. X and Y. Okay, let's do a circle. Take my vertical line, pass through it, I stop. How many times is it touching my circle? Twice, once on the top and once on the bottom. These are not functions because it touches it twice when I stopped my vertical line from scanning. Okay, now let's look at domain and range. So what we're going to do is, this is number 3. We're still going to be using, we're still going to be using our function. Find the range of the function. We now know it's a function. It passed the vertical line test. When the domain is. This is what they want you to do. They want you to find Y, range, when they give you X. And they want you to use this function. Now, I'm going to repeat. In your book, in your examples, you're going to have a different one. Please look to see what your book's function is. Look for it. All right, I'm going to tell you now how to do it. So what they give you is they give you 1x, x sub 1. They give you a second x, x sub 2. They give you a third x, x sub 3. And they want you to find the first y, the second y, and the third y using this example, this function, okay? So let's do that. Okay, so we're going to take y equals x plus 1. And we're going to take this first x right here, this one right here, and we're going to be substituting it in. I should actually make this arrow go right here. We're going to substitute it in for this x. So we're going to take out the x. Now, when I take the x out, I like to replace it with parentheses. So all I did, everybody, all I did was I just took this out and in its place put a set of parentheses. This is telling me where I'm going to put my number. This is going to help me substitute. Please, this is a good method to use. So instead of a blank space, I now know I'm going to put my -1 in. Then, in the calculator, all I do is put that side in. That's all I'm doing. So I'm going to turn it on. Now how to quit out of here, see this quit button? So I'm just going to press second mode, that quits. And so all I'm going to do is put in -1 in parentheses, add 1. That's it. Then you press enter. There is your first y value. So y1 equals 0. So this was y1. So our first y value, when we substituted our first x value, is -1. That's it. Now we're going to do our second one. So y sub 2 equals, I have parentheses plus 1. Because remember, I took that x out. I replaced it with parentheses because now I need to find my second y. So I'm going to now put in the second number they gave us, x sub 2. I'm going to put 0 in. So y2 equals, in my calculator, I am going to put parentheses 0 plus 1, and I get 1. 1. That is my second y. 1. Okay? So if I put in 0, I get out 1. That's it. Now let's find our third y. Again, my x is out. My parentheses are holding in the place. Who am I going to put in? I'm going to put in the 1. So y sub 3 equals 1 plus 1 is 2. Now, I know this is a simplistic equation. And I know I'm using parentheses and it's simple, but we're going to get into more complex one. And the sooner you start to learn to use parentheses, the easier and the more organized your work will be. So let's put that 2 in. So when I input 1, I get an output of 2. When I input my x sub 3, I get out my y sub 3. This is how to do those substitution ones. All right. Part B. Now we have a different type of problem. We have -1 is less than or equal to x, which is less than or equal to 2. They still give you a first x and a second x. However, it's just written in a different way. We're still going to go through and use our equation. This is part B. We're still using the same equation. We are still going to be finding our first y by taking the x out, replacing it with parentheses, and doing plus 1. The first one that we're going to input is going to be -1. So y1 equals -1 plus 1 is 0. Okay, we're going to do that for our second one as well. Here's parentheses plus 1. So y sub 2 equals, what's our second x? Our x sub 2 goes here, okay? Just in case you get confused. Now we're in x sub 2. 2 plus 1, so y sub 2 is 3. So we have our two numbers for x, but we have to write it correctly. This is how you write it correctly. This is a range of, this is a value, an interval of values. So x is from -1 to 2, including -1 to 2. We read this as -1 is less than or equal to x, which is less than or equal to 2. So we have to set up our range the same way. So our y is going to go in the middle because that's where our numbers are. Y is going to be in the middle. These arrows are both going to go the same way, less than and less than. This number right here will always be your smaller number. And this number right here will always be your larger number. So let's look at the answers that we got. All right, we have 0 and 3. Which one is smaller? Hopefully you said 0. Which one is larger? Hopefully you said 3. So this is our answer, how to write our answer given our domain. So here's the domain, here's the range. All right, let's look at an application problem, our last application problems with our last few examples. A special application measures the temperature of a person and records on a graph its variation from 37 degrees Celsius, considered to be the average optimum temperature. The application stops working when the temperature of the person is optimum. Before we even answer these questions, I want to explain to you what variation from 37 degrees is. If we look at this graph, on the bottom we have time in hours since application started to work. We start at 0, and we're counting by 0.2, 0.2, 0.4, 0.6, 0.8, 1 hour, 1.2, 1.4, 1.6, 1.8, 2 hours. Okay, that is labeled now as T. This is our x-axis, but they just relabeled it as T. That's fine. Let's look at the y-axis. Now, the y-axis is variation from 37. Notice we don't start at 37 here. We start at 0. Notice we don't go by 38, 39. We go by 0.5, 1, 1.5, 2, 2.5, 3. What does this mean? Okay, at 0, for the y-axis, which is now labeled as variation, 0 really represents 37 degrees Celsius. That's the optimum temperature. When you're at 0, your temperature is 37. Now, if we increase it to 1, if we're 1 above 37, you're right. This really means a temperature of 38. All right. If we increased it 2 from 37, this really means a temperature of 39. 3 above optimum, 3 plus 37, this really means an optimum temperature of 40. And you're right, 4 would be 41. I didn't do the little decimals. I just stuck with the whole numbers. This would just be 37.5. But I wanted you to understand what these numbers represent and how we would have to transform them if the problem asked us for temperature, we'd have to transform them into temperature. So you just can't say 4. If the problem asked for temperature, you would say 41 degrees Celsius. So be careful. State whether, part A. Now let's go answer the questions. State whether or not the relation represented in the graph is a function, giving the reason for your answer. So let's do the vertical line test. Okay, so when you have a graph, I think vertical line test. So let's take our vertical line. Let's scan it from left to right. If I stop on my graph anywhere, my pen is only hitting this curve once. Once. So passes vertical line test, function. That's it. Okay, let's go to part B. Part B says state the domain and the range. So we have to look back at our graph. Let's first tackle domain. Remember, domain is the x values. And when we look at domain, we're going to be looking at how far left and right our graph is. How far left and right. So let's go look at our graph. All right. So to the left, it starts here. To the right, it ends here. All right, so what numbers are those on the x-axis? Okay, well, it starts at 0 and it ends at 2. All right, so starts at 0, ends at 2. Where is x? X is all in the middle. And so it is 0 is less than or equal to x, which is less than or equal to 2, because that's where it spans. It goes from the left to the right. Started here on the left, ended here on the right. Started here on the left, ended here on the right. Let's look at range. So range is going to be y. So range is going to be how far up. Actually, let's do down and up. Down and up. So keeping that in mind, let's look at our graph. Okay, so how far, what's the lowest point? And I'm sorry, I'm making you erase. For those people who use pen, I apologize. Hopefully you have whiteout. So what is it? How far the lowest. I'm trying to get this perfect for everybody. The lowest and highest points. That's so much better. Okay, the lowest and highest points. Okay, so let's look at the lowest point. So the lowest point is over here. So where is that on the y? That's at 0. So we're looking here, the y's. Okay, that's at 0. That's the lowest point. Where's the highest point? This is called the maximum. The highest point is at 4, which is 41 degrees Celsius. But because we're talking about the graph and not temperature yet, we're just going to use 4. So on the y-axis, it goes from 0 is the lowest, 4 is the highest. 0 is the lowest, 4 is the highest, y is in the middle. State the independent and dependent variables. Okay, independent is your x variable. So you look on your x-axis, and that's time in hours. since application started. And you could just read that x-axis right here and it will tell you. In the y-axis, that's going to be your dependent variable, that's your output. So you look on your y-axis and that's your variation from 37 degrees Celsius. Okay. Last few problems. Let's part D, write down the missing coordinates for each ordered pair. This is reading the graph, everybody. Okay. So first, I'm gonna move this over. Okay. Here, first I label. This is going to be my T, this is going to be my V. Just like this is my X and this is my Y. So I'm just transforming it from X, Y over to what the problem is. So here they give you the X or the T. So what we're going to do is on our graph, we're going to go to the x-axis, which is our T here, okay? We're going to go to point 2. Here's point 2. We're going to go all the way up until we hit the graph. Once I hit the graph, I'm going to go all the way over, and I'm going to see that it's about 3.6. Okay, our next one, point 8. What do they give us? They give us the T. Oh, perfect, just like the other one. So I'm going to go over to my T. I'm going to go over to point 8. Again, I'm going to go all the way up until I hit the graph. I'm going to go all the way over, and my Y value, which is my V, looks like about 2.9. Next, okay, T, V. What do they give us here? They give us our V. So now we have to go on our y-axis. So now we go to 2. So here's our 2 on our V. We go all the way over till we hit our graph. Then we go all the way down and we find it's about 1.5. It's between 1.4 and 1.6. So 1.5. So you're reading the graph forwards and backwards. Okay? Here we have T and V. We're looking for our T, so we have to start on here. We're starting at 3, all the way over, all the way down. And that looks at about, let's see, 3, all the way over, all the way down, like 0.9. Oh, no, whoops, I'm sorry. That's where our graph starts. Look at that, right here. That's where our graph starts. That's not 0.9. What is that? That's 0. At 3, the graph starts taking off at 3. My apologies. That's 0. We don't have to go over at all. So that's actually the y-intercept. All right, and the last one, T and V. We have given T, so we go to the X here. We're going to look at 2. Oh, look at that. We don't go anywhere on the Y. So V is 0. This is actually our x-intercept. When you notice that one of these are going to be 0, it's one of your intercepts. Okay. Represent your answers in function notation. So what I'm going to do here is transform this to function notation. Function notation is when we write it V and we have an input. Our input here is 3.6. Input. No, sorry, 0.2. I'm rushing because I only have 2 minutes. All right, our input, in, out. So our input is 0.2. That equals our output of 3.6. Okay, next one. What do we put in? We put in 0.8. What did we get out? 2.9. Next one. What did we put in? 1.5. What did we get out? 2. Next one. What do we put in? 0. What do we get out? 3. Last one. What do we put in? 2. What do we get out? 0. This is another way of writing our answers, not as ordered pairs, but as function notation. There is another video to come up. The bell is going to ring, and I'm hoping the students are going to be quiet while coming in because I'm almost done. Use your ordered pairs to construct a table. I'm going to construct a horizontal table. This is going to be T. This is going to be V. And so let's write down what we have. Now, be careful because in a table, we need to put the T's in order. So our t, the lowest one is 0. Then we have 0.2, 0.8, 1.5, and 2. Okay? You have to put these in order. Sometimes I'll just write them down and then I'll switch them. Okay, who do we have for a t of 0? We have 3. A t of 0.2, we have 3.6. A t of 0.8, we have 2.9. A t of 1.5, we have 2. And a t of 2, we have 0. So all I did is I just matched all of these up from their ordered pairs. State the temperature of the person at the start of the application. All right, here's a hint. Anytime they say start or initial, they are looking for the y-intercept. Our y-intercept was 0.3 as stated above. As you can see, here is the y-intercept. I've said before, here's where it starts. So we just need the person's temperature. Okay, so be careful. They want the person's temperature. So it would be 37 degrees plus 3 plus 3. That's the variation. My bad. This is going to equal 40 degrees Celsius because this is what we have to add to my 37. All right, 2 more. After how many hours was the temperature of the person equal to 37 degrees? Okay, after how many hours is the person equal? So here, this is when they ended. When they ended, there was the x-axis. So here is the end point. So our end point is usually the x-intercept. Our x-intercept is going to be right here, 2, 0. And remember, this represents hours, so it took 2 hours. And our last one, everybody, during the period of time, did the temperature of the person increase? Over what period of time did it decrease? So all they want you to do is look at the graph, and they just want you to see where is the graph increasing. And so we see that the graph is increasing between 0 and this point right here. So let's see what time that is. So that's about between 0 and 0.5. So this is the part of the graph that goes up. That's what they want you to notice. So our increase is between 0 and 0.5 hours. Okay, let's look at the part of the graph where it's decreasing. So we're going to look here. Here, all of this is decreasing. It's going down. So we are just going to look to see. It's going down between 0.5 and 2. I'm wondering what's happening between those times. So decrease is between 0.5 and 2 hours. And that's it. This was a read the graph question. This has been Dr. Mears, and this has been Functions, your little introduction. Hope it helped.